Design of shell and tube type heat exchanger by using finite element analysis. Abstract engineers are continually being asked to improve processes and increase efficiency. These requests may arise as a result of need to increase throughput, increase probability, or accommodate capital limitations. The processes which use heat transfer equipment must frequently be improved for these reasons. This paper provides method for increasing efficiency of shell and tube heat exchanger performance by using rough surfaces and grooved tubes to increase surface area for heat transfer. External grooved surface on outside of tube, fins, make heat transfer faster because of more surface area. This paper also provides methods to improve turbulence inside the tubes of heat exchangers by using inserts. Main purpose of any heat exchanger is to exchange heat between hot fluid and cold fluid and reduce the temperature of hot water by giving its heat to the cold water. Due to this, heat exchanger finds its use in most of the devices working on thermal principles. Heat can be exchanged naturally between two substances at different temperatures, but heat exchanger boosts the speed of heat transfer and is hence has a very important part in industries. The heat exchanger used for this project is of shell and tube type, which is one of the most commonly used heat exchangers of today. Keywords: heat exchanger, thermal principles. Introduction: heat transfer is a device in which heat exchanges from one fluid to another fluid. Heat transfer takes place due to purely convection. Ultimate goal of this project is to enhance convective heat. Literature review: many authors worked on these heat exchanger devices. Some of the papers has been studied. R. Hosseini et al. According to these authors, heat transfer coefficient and pressure drop obtained from the experiment. N. S. Payaghan. Professor, RSCE Buldina MS. When their study focused on different copper tubes. Andre Lh et al. In their studies involved various problem-solving parameter according to nature of problem that includes heat transfer area, restriction, selection of different equations for solving pressure drop and velocity bound. This was reduced. Thermal stresses developed by the heat exchanger was reduced. Zhangfenguo et al. In this study involved design variable parameter of shell and tube heat exchanger, and to solve these algorithms applied the optimization problem. The objectives of this project are: to design a shell and tube heat exchanger, to increase heat transfer rate by making inner surface of tube rough and increasing outer surface area of tube by grooving, to use inserts to increase turbulence inside the tubes, to conclude effect of roughness, grooved surface and inserts on efficiency of heat exchanger. Project scope: since heat exchangers are widely used in every field, it is necessary to find out different methods to improve their efficiency, and that too in minimum cost. Efficiency of heat exchanger depends on various factors, heat transfer rate being one of them. This project is mainly concentrating on how to improve heat transfer rate of heat exchanger by using rough and grooved surfaces. Another factor for improving efficiency is turbulence of fluid experienced in tubes. Increasing turbulence to make heat transfer faster by convection is objective of this project. These simple techniques can improve efficiency of heat exchanger drastically with minimum cost. Design: the heat exchanger used in this project is of shell and tube type. It consists of a shell which is made up of polyvinyl chloride, PVC. The internal diameter of PVC pipe is 110 mm. The tubes are fin type and made up of copper. This heat exchanger consists of 5 copper tubes, each having an internal diameter of 12.6 mm. Copper is a very good conductor of heat, and finned copper tubes means more dissipation of heat to the surrounding, i.e. cold water in this case. The hot water is supposed to flow through the finned copper tubes and lose its heat to the cold water in the PVC shell as it progresses through the tube. A total of 4 holes are drilled on the PVC pipe. 2 for inlet and 2 for outlet of hot and cold water. The inlet and outlet of hot water are drilled at the opposite extreme ends of the PVC shell and are at an angle of 90 degrees with each other. The hot and cold water inlets and outlets are separated from each other with the help of 2 circular baffles, one in between the 2 inlets and one in between the 2 outlets. The baffle has a diameter equal to that of PVC pipe and consists of 5 holes of the same external diameter as of copper tubes for them to pass through it. Also, two semicircular baffles are placed in between the two circular baffles at 1/3 of the distance between two circular baffles. Conclusion. After all theoretical and practical calculations and testing prototype for different flows, we can conclude following points. Copper, already being good conductor of heat, it accelerates heat transfer. Copper also has many qualities like rust-proof, anti-fouling, corrosion-free, cheap, and easily available, makes it very useful for heat exchanger. Inserts are used in copper tubes. Inserts are twisted helically, such that water flowing through tubes moves in helically rotation, and inserts push them towards the wall of copper tubes, which helps in heat transfer. Also, inserts increase turbulence of water inside the tubes. With external fins made on copper tubes, it increases contact surface area, for convection heat transfer. Fins also make cold water turbulent while flowing from tube surface. In result of this, we found 20.15% of increase in heat transfer theoretically.